Good morning, everybody. It's really, really nice to be here for all sorts of reasons. Firstly, it's lovely to come and do some work with Doug. It's lovely to see all of you. I do a not dissimilar sort of thing to what Doug does, but not nearly as well at the University of Roehampton. But the particular resonance for me here is that I did my master's here, graduating back in 2007. So it is lovely to be back at one of my old universities. I don't put that in every slide deck. This is where I'm working now. This is the University of Roehampton. That's actually not where I work, that's where our Vice-Chancellor works. I have an office made out of breeze blocks some distance away from there. Before I came here, I did 18 years across 4 different schools, much of that time as an ICT coordinator. The last 3 years done as a head teacher, hence the prematurely grey hair. I'm not nearly as old as I look, but head teacher, very, very stressful job. Being at Roehampton, doing teacher training, much, much more fun. Roehampton, like a couple of other universities, is a collegiate institution. We made up, in fact, in our case, of 4 colleges. And I'm based in Froebel College. You've just heard of Friedrich Froebel. Oh, that's good. One or two of you. Friedrich Froebel, great 19th century German educationalist, renowned for a couple of things. Firstly, inventing the kindergarten, which is a pretty impressive thing to have invented. Okay, the press, or the printing press, the web, the wheel, fire, all of those modern inventions, but the kindergarten, got to be up there amongst those things. Who are the early years specialists? Okay, come and sit on the carpet front. No, you don't have to. Okay, what do you think about this as an early years setting? Do you think it would pass the CYFS Ofsted inspection? Touch and go in terms of adult-child ratio? Not so much, I'm not sure how much directed activity there is there. But what a rich, water-stimulating learning environment, isn't it? All of those opportunities for children to learn about the world, to learn about themselves, to learn about others, through the environment which they're part of. And, you know, with other people, with other children there too. The other thing Friedrich Froebel is famous for is coming up with this sequence of presents called the Froebel gifts, some of which look very similar to the thing on the slide behind you, the building blocks. So, early years questions particularly, why do we put things like that into the hands of small children? What are we hoping to do, or for them to learn, by giving them things like that to play with? This is not a rhetorical question, you're welcome to answer. Or not? Anyone? You're not friends. Froebel's idea was that through playing with things like that, they learn some of the fundamental things about the nature of reality. They spot the conservation of number. They spot the conservation of mass, the conservation of volume, all of this scheme which Piaget later came on to write about. They spot how gravity works, that things fall downwards. They don't just float in the air, when you position the block, something happens to it. They spot things about how static structures work. Some structures are more stable than others. And that's some of the reasons why we put these into the hands of children. Creativity would be another one. It's not, I don't think it is, so that they go on to become construction workers, is it? It's not so that they go on to become architects. It's because through playing with toys like this, they learn about the fundamental nature of reality. Of course, some will. And the great American architect Frank Lloyd Wright went to a Froebel kindergarten in America. And you know, there are those who argue that his later architectural work was influenced by his early childhood experience. But some of the children who play with these things will go on to do that. What about in terms of computing? What about in terms of ICT? Who here has used Scratch? A handful of hands. Simon's going to be telling you lots more about Scratch later on in the day. And this is developed by the group MIT called the Lifelong Kindergarten Group. And there's no coincidence in there. And the reason why people like Mitch Resnick and people like me think Scratch is a great tool to put into the hands of children in primary age is not, despite what we might have heard in the media, so that they can go off and become software developers and computer scientists and programmers and coders and hackers and all of those lovely, interesting things to do. It's because through playing with those sorts of building blocks, they get to understand something of the fundamental nature of reality and how the world is. And that's kind of where we're going to with the new computing curriculum. So you'll be familiar, I'm sure, with Piaget and the notion of schema, that learning at its heart, according to Piaget and constructivists, is about developing this model of how the world works. And how do you do that as a small child? How do you do that as a grown-up? I mean, part it's through playing with objects, it's playing with stuff. It's through that direct experience of moving things around and trying to build things through them. And so that's what young Sophie is doing. This is my daughter, on whom I dote. This was taken about a year ago. What's she doing there? What she's doing is playing, literally playing with a computer. Through playing with a computer there, she is developing some schema, some understanding, some mental model of how that technology works. The first experience of these things is when I close the lid of the laptop, Daddy pays me more attention, or Mummy pays me more attention. Later on, probably by about that stage, she's spotting that this button makes it wake up. And maybe my finger over this bit and things happen. I tap for someone who squares and things happen on screen. So this notion of input, process, output is right there. I would argue from that age of 14, 15 months. But she knows she does something, the computer does things, and then things change on screen or through the speakers or whatever. And those of you who studied ICT at A-level, anybody studied ICT at A-level? Okay, I'm not ashamed to have this in front of your friends, that's really good. Okay. Do you remember that whole input, process, output thing? Yeah? This is the model that we teach of how the technology works. And okay, at this stage, the process for Sophie may be something to do with magical pixies or fairies inside the machine. I don't know, she's not telling me what she thinks is happening. But that understanding of the process and how computers relate the input to the output is something which will develop and change as they learn more through the direct experience of objects, as Piaget talks about. Okay, the question I'm asking about is who wrote this quote? The question I can't ask you that because I don't know if Doug makes you all read this answer. But can you see that okay from the back of the room? Anybody want me to read this out loud? All right, have a read of the words on the screen and tell me if you know who wrote it. And if not, then have a guess when it was written. Okay, I shouldn't put the photo on. Anybody like to specify the author? Suggest a date? So Seymour Papert, writing back in 1980. I wonder how much of that has changed over the intervening 33 years. How many of you on school experience? For you, was the ICT lesson that you went to teach or to observe something about beyond mathematics and going to Education City and play some of these games? Anybody? A few of you, thankfully only a few of you. But isn't that what he's talking about in that paragraph there? The computer programming the child. There's nothing wrong with it, it's fine. You know, there's a place for practicing your tables and practicing your spellings. There really is. But the vision here is about taking control of the technology. Douglas Rushkoff's book, Program Will Be Programmed, sums it up beautifully in that title. We want a generation of young people that are capable of taking charge of that technology rather than the technology taking charge of them. And it is actually through playing with this sort of technology, playing with these ideas, that we get this understanding, not just of the tech itself, but about some of the fundamental nature of reality, deepest ideas from science, from maths, and from the art of intellectual model building. So, as with so much of the new national curriculum, back to how things were a good 30-odd years ago. Demos, writing back in 2007, talked about young people and their use of technology. This is people at school, secondary school. Broadly speaking, by the time they get to secondary school, they're not bad at the top two on that list. They're reasonably good at finding things out on the net. You know, those of you who are based in year 6 on your last placement, which child would you talk to in there who said research this, and they would not immediately go to a particular search engine? Anybody teaching children to go and look things up in books first before going onto the web? Okay. And when I say search engine, you all know which one I mean, don't you? They're pretty good at finding things out. They're pretty good at staying in touch with one another. Okay, they shouldn't have Facebook accounts, but many of them do. They probably have mobile phones. They're perfectly capable of staying in touch using technology in one sort or another. What they're not so good at, according to Demos, is being these creative producers of digital content and being the digital pioneers, those who are pushing forward the boundaries of what they can do with the technology. Who here has heard of Assessment for Learning, AFL? Okay, that's more than a scattering of hands. That's really good to see. Anybody familiar with TFL? Not Transport for London. Okay, hand goes down. Thank you very much. I'm talking here about not assessment for learning, but a radical new idea, which I kind of coined myself, called teaching for learning. You're welcome to use that in your essay, you really are. Okay. And what it boils down to is meeting children where they are and taking them on to some place where they wouldn't have got otherwise. You know, a bit like Transport for London, I suppose, in that sense. So where do we meet them? What are they good at? Well, again, it's easy to generalise here. There are exceptions to this as to every rule. But broadly speaking, by the time they leave primary school, thanks to the great work that goes on in the classroom and children's access to technology, they're not bad at using technology, are they? They're not bad at that. They're pretty good at consuming digital content. They can get onto YouTube, they can download music either legally or illegally off the web or listen to it online on Spotify or whatever. They're good at staying in touch, they're good at everyday communicators, as Demos reported back in 2007, 6 years ago now. They are, for some values, of digitally literate. They're able to read and write in a digital domain. They're not bad, thanks to the good work that goes on, and let's not generalise or assume here, good at keeping themselves safe. They know the strange danger stuff in the online domain. And they have a whole cluster of skills that they can take with them to secondary school. Does anybody want to contradict me or argue with me now, or do you want to do that on Twitter later? Okay. Because, you know, as I say, it is easy to make assumptions here. So where do we take them on to? And this is kind of some of the things that's underpinning where we're going with the new curriculum. We meet them as users of technology, and we take them on to become makers of technology. We meet them as consumers of content and transform them into creators of content in that digital domain. They're good at communicating online, not so good at collaborating online and working together purposefully with one another. So let's do that with them and do that for them. Yeah, they're fine at reading and writing online and finding things on Google, that's it. But how critical are they of the stuff which they find? How many of them know how Google chooses what it puts top of the list? Just out of interest, how many of you know how Google chooses what it puts top of the list? All right. They're good at keeping themselves safe. I worry more about how good they are at being responsible online. You know, how many of your placement schools, you don't have to put your hand up for this one, had cyberbullying issues? I suspect more than a few, okay? How many of them had issues with children being groomed or being inappropriate contact, I would hope banishingly small in their name? So moving from safety to responsibility. And yes, this is the beat. This is the real change in the curriculum. It's not the programming stuff, it's not even the computer science stuff. It is this change from skills to understanding. You would not get away with it in maths, you would not get away with it in any other subject to say, oh, it doesn't matter how it works, all that matters is that you have to do that. Try saying that in your next maths lecture. I don't need to know how division works, all I need to be able to do is follow the written algorithms or do. Yeah, you'd be totally go and sit outside and change your ideas. But in ICT, we focus so much on developing a set of skills and not nearly enough on developing children's, young people's understanding of how it works. So let's go to that. If you look back at the development of these curricula, 2009, Jim Rose did a great bit of work for the then government about reviewing primary curriculum. Said ICT should be there at the core of the curriculum alongside literacy and numeracy as something which is essential for learning and for life. But just as you need to be able to read and write and do a bit of sums in order to get any job or access any sort of learning beyond school, similarly now you need to be able to use the technology like that. It belongs there, said Rose. Not as a subject in its own right, but as something which is there at the heart of the curriculum, as he says, essential for learning and life. This is his definition, or him and his team's definition, of what ICT capability encompasses. I do an exercise with my trainees about, what do you think ICT capability means? And broadly speaking, they get all of the words which Jim Rose was no doubt paying quite a lot of money in order to come up with himself. Is there anything on that list which surprises anybody in the room? Okay. It's a reasonably good working definition which most of us would probably be able to come up with. Certainly we wouldn't pay as much as Jim Rose to produce this. Yeah? Notice it isn't just skills, there's knowledge and understanding there as well. Notice the thing about competence and confidence. Notice the thing about independence. Yeah? I hope, looking around the room, most of you would be able to say, yeah, that's kind of what I can do. I'm pretty good at that. I know, I can use the technology, I have a good idea of how it works. I'm confident, I'm independent. Somebody doesn't have to tell me how to use these programs. I can figure it out for myself. Yes, no? Maybe. Okay. We do a similar sort of exercise as I say with Roehampton students. Now, this is too small for people at the back of the room. This is at the beginning of the course, the incoming PGCE cohort. People like yourselves to train to become primary teachers. 18 different skills. What are you good at? What are you not so good at? And the things up at the top of the list, they're pretty good at. Apparently, Roehampton students, over 90% of them are competent, proficient, or expert at using social media. Probably a similar figure at Leicester? Yeah, I thought so. Okay, so that's not something which we feel we have to kind of teach on the course. Further down the list, this one really surprised me. Using interactive whiteboards, I've got 40-odd% of my new PGCE students who've never used an interactive whiteboard before, or say that they haven't. Yeah? And relatively few who've got a level of competence, proficiency, or expertise with that. But the one at the bottom is the issue, of course, for the new curriculum. Look at this programming figure. More than 3/4 of them say they've never programmed before. Can I do a show of hands for this? Okay, some of you are admitted to using Scratch, but who here would be in that red bar of never having done any programming in their life? Okay, why are they sat at the back of the room? You sort of agree. Okay, well that's certainly more positive than the Roehampton picture. Okay, but that's going to be such an important skill. How are you going to teach children to do this if you can't do it yourself? Well, we can do some really inventive pedagogy. We can be partners, we can be guides on the side rather than sages on the stage. But sooner or later you're going to want some subject knowledge to draw on. Okay, this is what so Jim Rose, lovely, warm, friendly statement like that, all of us can quite happy with this. The new curriculum for computing starts with this statement. This is in the preamble. And again, I'll give you a moment to have a look through that. And does that not strike you as really quite different from what we've done before? Yeah? This is a body of knowledge in its own right. It's not about skills anymore, important as they are. We will be creating purposeful and useful articles. But this is about understanding the world through the lens of computer science and the insights which that brings. And that's the change from skills in using technology to an understanding of the world through the lens of technology. Okay? There are one or two problems with that. I look forward to seeing how your schools respond to Ofsted saying, how has your computing education equipped pupils to change the world through computational thinking? Okay, we'll see how that goes, won't we? Okay, so we asked the same question about skills. Skills, as I say, Roehampton students do pretty well on. I then asked them, how do you grade your own knowledge? How do you grade your own understanding? And that's the one that worries me in terms of my trainees. And, these are young people, these are curious people, they're like yourselves. For two further generations up of the profession, this is the real one for me in terms of this. The skills we're fine, actually. Understanding, what's this? This is only about half of them. Say on the form, I have no understanding of how technology works. I have, less than 15% of them who grade themselves as competent, proficient, or expert when it comes to their understanding of technology. And that is going to be the real challenge, not teaching folks how to use Scratch. That's just like another program, for pity's sake. but developing that understanding of how the technology works. Okay, how are we doing for time? Right, who's familiar with waterfall development methodology? You are, because you did A-level ICT. Anybody else in the room knows what the waterfall development methodology is? Okay. Do you want to explain to everyone? No, I'll do it. So, if those who teach A-level ICT have this thing on the subject specifications of the exams about this is how software gets written. You have people who wear very, very nice suits, okay, usually bespoke suits, who come up with a list of requirements. The software should do this. Other people who generally don't wear such nice suits will come up with a list of requirements. Sorry, come up with a design for what the software's got to do. Okay, they will take that list of functional requirements and implement that as a technical specification. Other people, generally not wearing suits, generally significantly less well paid, generally not having much say in the whole process here, have the job of implementing that specification in the form of code. Then there's typically other people test whether the code works and does the job properly, and then usually you've got a bit of sort of ticking over contract so that you can go and make sure that the software carries on working and the clients are using it properly. Having kind of got that about the way compared to what you taught today? That's all right. Okay? We have a not dissimilar approach. Oh, and it's worth saying that this is renowned for working incredibly well, such as big government IT projects like the NHS database. Okay, we're not. This is how we also do curriculum, though, isn't it? In person, usually wearing a suit, often these days wearing sort of rather sort of heavy spectacles with a certain design look to it, a little bit novelized, you know what I'm talking about. It comes up with a set of requirements. We need to treat computer science, I'm going to try and do the accent. Other people wearing suits, generally not as well paid, obviously, meet together in hotel basements or function rooms of the Royal Academy of Engineering and come up with a design to implement that vision, if you're allowed to have this particular case. Still, other people, generally not so well paid, generally with little say in the process, have the job of implementing that design. In our line of work, we call them teachers. We do a huge amount of testing, as you know, checking that this has worked, checking that it's been implemented properly, and then once in a while we'll send out a reminder, QCA schemes of work. This is how you were supposed to do it in the first place, the service pack, if you will. So just as that definitely works well for public sector IT procurement, so it's bound to work well when it comes to public sector curriculum specification, isn't it? This is still around. You can still get a copy of this. This is the old 99 National Curriculum for ICT, which only ceased to be enforced for primary schools September of this year. So up until this academic year, this is what primary schools are teaching. Who remembers using a computer back in 1999? Windows 98? Windows 80 if you were really unlucky. Do you notice how Microsoft operating systems go good, then bad, all the way through? Windows 7 was fine, Windows 8, I'm making no comments. Okay, CD-ROMs, software on CD-ROMs, connecting to the internet and going, yeah? So a while ago now. Nevertheless, the team who drew that up, and reference to people who were on the team and in the room, they did a fine job with this. They really did. They hardly mentioned any technology, and thus it has stayed the test of time well, despite all the changes. Which of those things do you not want your children to learn when they're in school doing ICT lessons? In fact, reviewing, modifying, evaluating work as it progresses, don't just leave that to the ICT lessons, folks. Really, that's something you kind of want to do across the curriculum, isn't it? Yes, indeed, is exchanging and sharing information. Nevertheless, when implemented in practice, you know what's happened, because most of you look young enough to have sat through these lessons. It turns into this is how you use a particular proprietary brand of office software, and that was meant as a lowercase o, but you could put a capital O in between if you wish. Yeah, that's how the ICT lessons become how to use PowerPoint, Excel, and Word. Didn't they? Yes, isn't this what your experience was at school yourself? And that's missing the point. At no point here did it say anything about spreadsheets, did it say anything about presentation software, and yet that's what we've ended up doing. So something must be done. Various people become discontented about this. This is one of them. The Department of Culture, Media and Sport commissioned Ian Livingstone, great computer games developer. Anybody play Tomb Raider? Okay, Ian Livingstone, the man behind Lara Croft in at least one sense, yeah? And Alex Hope, who's pioneer of the UK visual effects industry, were commissioned to write this report about what can be done to restore the visual effects industry and the UK games industry to its top place in the world ranking. And they said, recommendation number 1, put computer science on the curriculum. Okay, it was never off the curriculum. There was at least some aspects of computer science in the old ICT curriculum, but focusing the attention on that rather than training how to use Office software. And then you get this man. Who's Eric Schmidt? Somebody said it. He's the executive chairman of Google. Google, remember, the organisation which controls more people's access to information than pretty much anybody since the Reformation, I thought. And Google, one of the top 3 working there. So with a little bit of luck, we should be able to get some sound. We'll see.
I was flabbergasted to learn
Maybe not.
that today computer science is not even taught as standard in schools.
I don't think I can make that happen. Technology. What he's talking about here is the UK throwing away its great computer.
This risks throwing away a great computing heritage.
Like Charles Babbage and Alan Turing and Tim Berners-Lee. If you don't know these 3 names, you need to look them up on Wikipedia or somewhere else soon, okay, as part of our heritage. And yet Schmidt says, because we're not teaching computer science, we're throwing that heritage away. You know, things like the BBC Micro. The Royal Society reporting after 18 months of research on this about what can be done about the state of computing in schools, and they see part of the problem as the brand of ICT. It's damaged goods because it's been seen as just this sort of office skills preparation, which it has never been in the best schools, to be fair. And so they say, let's rebrand this as computing, and let's think about what that actually means, what should be part of a computing curriculum, and they come up with this singularly helpful diagram, ICT bad. Let's call it computing, and let's identify 3 aspects of this as computer science, information technology, and digital literacy. If you want my handle on thinking of those, then you've got the foundations of the subject, you've got the applications of that, and then the implications of that for us as individuals and for us as society. And I think that's probably more helpful than those 3 sets of words. But, you know, your mileage may vary. And then the Secretary of State, blessing. Regrettably, I can't get the speakers to work, so you can't hear a message from the Secretary of State this morning. That's such a shame, isn't it? Yes. Okay. Talking about in January of 2012, saying that what we need to do is get away from the old ICT curriculum so teachers have the freedom to teach all of these really interesting and exciting bits of the subject. And that's the state we're in at the moment. We have this 2-year period of disapplication, where he's used his executive powers to say you don't have to follow a program of study for the ICT curriculum, you've still got to teach ICT, but you as a school choose what you want to do in those lessons. I'm sure you will have seen from placement all of the schools that have immediately said, at last we can teach loads of computer science, because the reason why they've not been doing that is because nothing in the previous national curriculum told us that we had to. Yeah? Did you find that on placement? Loads of computer science happening in your schools? Despite disapplication, I'm astonished. Frankly, I am absolutely astonished that what he said was going to happen hasn't happened. We kind of wrote to him, or a number of us wrote to him and said, look, if you want to see computing there in schools, then just letting schools choose what they do and saying ICT is part of the basic curriculum, doesn't matter, you get to choose whatever you want, then that's not the way to make it happen. And so he actually changes his mind. He ignores the expert advice from the National Curriculum Expert Panel. He kind of reverses his position from the vet, saying, he says, the government has made it clear that it considers ICT to be an important subject taught to all pupils. As a clear statement, we're going to put it back as a national curriculum subject with a statutory curriculum study from September 2014. So that's the commitment we made last June. We will have ICT there with a statutory program study, alongside all of the other national curriculum subjects. Unlike all of the other subjects, he's going to do it differently. So, rather than behind closed doors in sanctuary buildings, he says, let's get the experts, the British Computer Society, Royal Academy of Engineering, to act as honest brokers, to gather together stakeholders and produce expert advice on what the curriculum should look like. The process, which started last August, and I was part of this, was roughly as outlined on the screen there. It was done in a relatively open way. We produced a draft at the end of October. We had consultation meetings about the draft. We responded to what teachers and others say. Doug responded to this, and we got some of his words there in the draft that went off to the Secretary of State. Playing in the draft was down to Doug and the rest of the people he was working with. So credit where credit's due. And so that then goes off to the DFE. I think we were due to hand it in 30th of November. I think we got it into about 4:45 on 30th of November. So, when you've got those essay deadlines, it's not just you. That's sort of time management. The DFE then have a look at what we handed in and say, could you go away and do it again properly? But rather than saying that to us, they say that to just a very small group from BCS and Royal Academy of Engineering themselves, and they asked a number of changes to be made. For a start, they want the bit which Doug put in about play taken out. That's what they actually said. But that's not different. It's just blue pencil. But, it's not about how you teach it, and of course we will surely continue to play with computers. It's about the subject, content. So this is, and if you want to know more about the process, then bcs.org/ictpos. You can see the draft that we sent in. You can see some of the guidance notes, 2 pages of curriculum, I think 7 pages of guidance notes, go figure, and some of the process details there. And then on the 7th of February, it stands up in the House of Commons and says, we're going to put we have also replaced the old ICT curriculum with a new computing curriculum, changes the name of the subject, with help from Google, Facebook, and some of Britain's most brilliant computer scientists, oh, and Miles, of course. I don't actually remember the person from Facebook saying anything in any of the meetings. Perhaps they just liked what he'd done. If we had more time, I need to kind of finish by 10 so you can go off and do more interesting things. I do actually... No, we don't have time to do it properly. I'd like you, for homework, go and think about what the curriculum should be for. And have you done what is the purpose of education? Is that lecture number 0 on the course? I hope so, because these are fundamental questions. And if you're planning a curriculum, you really do need to start thinking about what it is for. Fortunately, the work is done for you. The 2002 Act makes it very, very clear what the national curriculum, and this curriculum at any school, is for. And it is preparing children for their future, for our future. Summed up here, you have the curriculum for any school must promote the spiritual, moral, cultural, mental, and physical development of pupils at the school and of society. There's one for your head teacher when you get back onto placement. How is our school curriculum promoting the physical development of society? But never mind. It must also prepare pupils for the opportunities, responsibilities, and experiences of later life. So the statutory requirement for curriculum is to look to the future, to ensure their development, and to prepare for the opportunities to come. He moves away from that in the new national curriculum, though. The aims for the national curriculum, which is only part of any school's curriculum, remember, are quite different. He unashamedly says the national curriculum is about the transmission of the best that has been thought and said, the transmission of what we as a culture, we as a society, we as a species have learned, have discovered to the next generation. Neil Clay, who used to work at Leicester, makes a really interesting point. For a long time in our history as a species, the two were the same. Preparing for the future involved a really good knowledge of the past. Yeah, on the other, it's about how do you survive the attack on the saber-tooth tiger, probably going anachronistic here, by doing what your forefathers have always done to survive the attack on the saber-tooth tiger. Do you not think, though, that now things are a little bit different? That preparing children you teach for their future involves something different from what you were taught yourselves when you were at school. The rapid pace of change in society is so fast that an adequate preparation for the future, our statutory obligation, is more than just a knowledge of the best that has been thought and said. So this is the computing curriculum. It takes as its structure, if you will, that vision from the Royal Society, which contains both an understanding of the computer science bits, those foundations of the subject, but also includes their applications in information technology, how you use the software, how you make things, how you get things done, and some elements of digital literacy, which I would very much encourage you to think of in terms of the implications of what this technology means for us as people and for us as a society. We have 4 aims, not 3 aims, not 5 aims, but 4. First is about that foundational computer science thing, which is more than just programming. It's the understanding of the ideas of computation, of how software, that's more than just how software works. It is the fundamental ideas about algorithms, about doing things one step at a time, about working logically, about how data is represented, yeah, the understanding stuff. We then have the actual practical skill of programming and coding, which is going to be so much more fun to teach than that foundation stuff, I'd have thought. We then want them to be able to apply and evaluate IT, and we want them to end up as responsive, competent, creative users of the technology. If you want to see that as digital literacy, I don't think you'd be far away from the truth of that. There was a 5th aim, but that was about this more critical appreciation of digital technology. That was removed at request of ministers. So then we get into the detail at last, and I've got 5 minutes to cover the whole of the programme. So now, preamble. So key stage 1, you have these 5 things to teach over the course of 2 years there. The top one worries loads of primary practitioners who say to themselves, what's an algorithm? Who in the room feels that they know what an algorithm is? Okay. Is that sort of maths specialist over there? Okay. This is the term which you will meet in maths as well. You know, the written algorithms of doing long multiplication and long division and all of that stuff, which comes back onto the maths curriculum, is part and parcel of that. We're talking about a set of instructions to get something done, to solve a problem, to achieve a particular outcome. Simon's going to talk more about this in his workshop. Have I stolen your thunder there, Simon? No. Okay. And for my next trick, I'm going to go through the whole scratch in 5 minutes. Yes? No. So you've got that thinking about solving things in a step-by-step sort of way. You also have the practical experience of writing programs. He does not say, quite deliberately, does not say on a computer, by which we will assume you mean a laptop or a desktop computer. Yeah? Who here has used bbots? Yeah? You can do all of this with a bbot. I wouldn't say that was a particularly wise approach, being as they'll have used bbots in early years, and including reception. But you can do all of those first 3 statements by just playing with bbots. You really can. But you might want to move on to sort of screen turtle space. The 4th bullet point there allows you to do whatever you wanted to do anyhow. Remember, the national curriculum is a minimum, not a maximum, so you can do whatever you want as well as this. But the 4th bullet point, organise, store, manipulate, retrieve data in a range of formats. Can you think of anything you might have taught in an ICT lesson which is not covered by organising, storing, manipulating, and retrieving data in a range of formats? They're making video, painting a picture, writing, doing word up. All of that covered by that bullet point. If you need to have cover by the bullet point. You might do it because it's a thing worth doing anyhow. Notice that e-safety comes in, as does responsible use there. And indeed, common uses of IT beyond school. Key stage 2, 2 slides of key stage 2. This is the more programming geeky type thing. Those of you who use Scratch, you can cover all of those top 3 bullet points within about a lesson, or maybe 2 or 3 lessons, by doing some games in Scratch. So a simple drill practice, maths game like education system, like mathematics, can cover those 3 points. You need to keep track of their score, or have a time limit. You need to say whether the answer to the question is right or wrong. You need to keep asking questions until they get to a certain score, or the time runs out. Yeah? There's the bones of an algorithm there. Writing a program to accomplish a specific goal. Okay, I'm not simulating a physical system, to be fair, apart from a computer, which is, of course, a physical system. Decomposing the problem into smaller parts, well, we need to deal with the detail of how we create the questions, I suppose. Sequence, putting the steps into order. Selection, ifs and thens. Repetition, keep doing it until the time runs out, or no. And then you go and test the thing and tweak it until it works. So, games in Scratch, drill and practice in Scratch, covers those first 3 bullet points. Oh, yeah, you're going to explain how it looks to somebody and correct the errors in there. This one Absolutely great fun. You'll have a whale of time explaining the difference between the internet and the web. Hands up if you can explain the difference between the internet and the web. Excellent. Okay. John Norton writing in last Sunday's Observer. Brilliant article about that. Go and have a look for it. Google John Norton Internet Web. You should get there. Okay. So the internet and how it provides multiple services like email, like Skype, like the web, and the difference between those. And lovely, lovely bit in here, the opportunities they offer for communication and collaboration. Go to Julia Skinner's workshops. She'll give you some really nice examples of the opportunity the web offers for communication and collaboration. Okay, this one, top one here, I don't know what you're going to do with that one. It's a really good one. This was added since in that legal reading. Okay, describe how internet search engines, firstly, they're not internet search engines. They're web search engines, see previous bullet points. Describe how internet search engines find and store data. I could do a pretty good attempt at explaining how Google finds data. Explaining how Google stores data is really hard, or really trivial. You just say on disk in a table and have done it. Show them some photos of Google data centers, find a stormtrooper, job done. If you want to do it properly, you've got to talk about things like big table and GFS. Anybody else in the room know what big table and GFS is? Okay. I don't think that's what they meant. But of course, there are ways to tell children simple explanations to help them towards deeper understanding. But, you know, how an internet search engine stores data, you've got to work with that. And then the last bullet point here allows you to do anything you want, and even if you need permission to do anything you want. Yeah? My friend Ian Anderson teaches down in Hampshire. Select, use, and combine a variety of software and range of devices to accomplish given goals. Showed that to his year 4s. They sent him. Mr. Anderson, do you mean like use stuff on stuff to do stuff? He says, yeah, that's pretty much what it means. So using stuff on stuff to do stuff, that's covered in the national curriculum. You're going to have to teach using stuff on stuff to do stuff. Okay? So we can carry on doing some of what we've been doing. I'm out of time. Key Stage 3 is really bad. You thought some of that in Key Stage 2 was bad. You just wait till they get to Key Stage 3. And there's more. And there's more. Key Stage 4, where are we going to go with Key Stage 4? That's it. Okay? 3 years of Key Stage 3. Key Stage 4, just keep calm and carry on coding, I think is the phrase we're looking for there. If you want to say, Miles, that's rubbish, please do. Okay, I have to take some responsibility for at least some of this. There are other bits which aren't how I left them. Okay. Do that by email, do that by Twitter. But more importantly than letting me know you think it's rubbish, could you let the Secretary of State know you think it's rubbish, please? You've got until the 16th of April, which is soon, that's like a week tomorrow, to get in a consultation response. Don't have to fill in the whole of the form, just do the ICT on the computing bit and say it needs to include creativity at Key Stages 1 and 2, and e-safety at Key Stages 3 and 4. We make those two changes, we'll have a much, much better computing curriculum as a result. And try and get it by the 16th of April. Please. We should see the final version for next September, with the final version to become statutory in September 2014, unless you're teaching in a free school, an academy, or an independent school, when you can do whatever you want. Anyhow, yeah, Ofsted stuff. Oh yeah, the other thing, you do know that level descriptors, attainment levels are all going? You spotted that? Okay, that's going to be a real challenge for the profession as a whole. So badges is one interesting way, and we're waiting to hear what the department think we should do. These are some of the challenges ahead, which I've not got time to talk about. But you can get in touch. Please do. You know, there's an email address up there. There's a blog which is very, very rarely maintained. Part of these things, and there's the whole quick thing if you'd like to get in touch afterwards. I'm so sorry I've overran, particularly to my colleagues who presented workshops 3 minutes ago. Thank you all very much for your questions.